I just want to address a couple things with fractions. And one of the important things with fractions is that we always make sure we're referring to the denominator of fractions as equal parts, not just the denominator. The big key concept for students to understand is that the denominator represents equal parts. We oftentimes want to use pizza or circle diagrams to show fractions to students. These are great ways to get students to understand fractions to begin with, but we want to be able to find other models to help students when we're adding and subtracting fractions because the circle diagrams are not quite as easy to compare. So if we like working with food, we can talk about candy bars because strip diagrams or take diagrams looking at rectangles are a little bit easier to line up and for students to compare fractions and compare the number of equal parts of a fraction. So one of the misconceptions that students have is that when we add or subtract fractions, we add and subtract the numerator as well. For example, 1/4 plus 1/4 equals 2/8 is one common misconception that students have. So they oftentimes think that 1/4 plus 1/4 equals 2/8. And one thing we can do is use strip diagrams to show that this is not true. This is a great way to take care of a misconception before it becomes a habit, that we will show that this is not equal to 2/8. So a strip diagram starts by making a rectangle. And in a rectangle, I'm going to be adding fourths. So I'm going to split my rectangle into equal fourths, 4 equal parts. So this rectangle is one whole split into 4 equal parts. Now I'm going to take 1/4, so one of those 4 equal parts, and I'm going to add to that another one of those 4 equal parts. And now we can show students that we actually have 2 of the 4 equal parts, not 8 equal parts. And 2 of the 4 equal parts, the students can also see that is really equal to 1/2 of the whole. So this is representing 1/2 of the whole. This we can look at as 2 of the 4 equal parts. So the way we represent fractions and the way we use our language is going to be very important for students. So we want to make sure that we're talking about the whole and equal parts. How can we use strip diagrams or tape diagrams to add fractions with unlike denominators? That time we saw an example with like denominators. What would this look like with unlike denominators? Let's add 2/3 plus 1/4 and see what this will look like. 2/3 in a strip diagram, I make a whole. There's my whole, and I need to split this into 3 equal parts. So I need to do the best I can to make them equal. I know that it's by eyeing it, it's not always perfect, but we want to be as precise as we can if we're not using a ruler. So 3 equal parts of this whole. My next fraction is going to be in another strip diagram, which also needs to be the same length because the whole is the same amount. So our strip diagrams need to be the same length. Now this fraction will be split into 4 equal parts because the denominator shows 4 equal parts. So I have a whole split into 3 equal parts, and I need 2 of those equal parts. 1, 2. In the bottom fraction, for the second fraction, I have 1/4. So I need 1 of my 4 equal parts. Now what the students can see is that the hard thing with adding these is that my equal parts aren't the same. The equal parts in this fraction are different than the equal parts in this fraction, but they're the same whole. So now we can talk about, well, how can we make them equal parts? How can we make them the same size equal parts so that we can add those together? If I trace up here, this line matches right here, this line matches right here. And up here, this one comes down here, and so forth. And what we will start to do as we fill this in is recognize that all of these 3 equal parts, I'm actually going to split into 4 equal parts. So I'm using dotted lines here to kind of represent my new equal parts. Now, down here then, all of these 4 equal parts will be split into 3 equal parts. So now that I can see when they're lined up. This is why I like strip diagrams instead of circle diagrams, because I can see them lined up right next to each other, that those are the same size, and those are the same size, and those are the same size, and so forth. The students can visually see that we have equal sized, equal parts in both fractions. So now when I take my three new equal parts down here, I can fill those in up here. There's one, and there's one. So my new shaded area is 11 of, if the students count it, they will see 11 equal parts out of 12 equal parts. So 11 parts are shaded of the 12 equal parts. And this would then lead us into eventually being able to find common denominators without a visual. But students can see why we need to find common denominators or common equal parts to add fractions.